In example 8 on page 125, we are given a line and a plane. So the first thing that will cross your mind is, what is the relationship between this line and this plane? So between line and plane, I would like to suggest to you that the first thing that you always do is to check, okay? Is to check whether or not the line is parallel to the plane or not. Do you think that this line is parallel to the plane? In this case, just imagine, for a line to be parallel to the plane, what must happen? If this is a plane and this is a line, if a line is parallel to a plane, like what I discussed in the earlier video, the directional vector of the line and the normal of the plane, what can you say about them? These two vectors are perpendicular. So let's see again. In this case, line L1 is parallel to pi because this vector 1, 1, minus 1 dot with 1, 2, 3 indeed gives you 0. So therefore, I am sure that the line L1 is parallel to the plane. So once it is parallel to the plane, the next thing that we are interested to know is it the case of the line is lying on the plane, or is it the case where it is just like this? So now to check whether or not is it the first or second case, you just imagine you take a point on the line and you ask, given that the line is already parallel to a plane, if this were to happen, then the entire line is on the plane. If this were to happen, then the line is just parallel but not on the plane at all. So how do you check whether or not is this or this? You simply check whether or not this point is on the plane. So how do you check? So let's check again. Let's check whether or not this point 155 is on the plane or not. So take the point 155. You dot with 1, 2, 3. You get 26. Right, if you get 26, that means the point 155 is on the plane. So 155, therefore this point at 155 is on pi, on the plane pi. So by 1 and 2, L lies in pi, the plane pi. Okay, this is how you can actually check. In example 9, you have similar thing. In example 9, you are given a line L2 is R equals to, let me write in column vector form, 2 minus 1, 0 plus mu of, 2 minus 1, 0 plus 0, 3 minus 2. And then the plane pi is R dot 1, 2, 3 equals to 26. So the same thing goes. First step, you check. Are they parallel? Is L2 parallel to plane pi? Because 0, 3 minus 2 dot with 1, 2, 3 indeed is 0. Then what do you do in step 2? In step 2, what you do is you take this point 2 minus 1, 0, you dot with 1, 2, 3. And in this case, you get a value of 0, which is not 26. So it means 2 minus 1, 0 is not in the plane. So by 1 and 2, L2 is just parallel but not lying in pi. Right, that's example number 9. Now we are on page 127. Example 10. You are given a line L that passes through 2 points. So I can immediately write down the equation on line L is 0, 1, minus 3 plus lambda of, to find the equation of line, you need two things, right? This second vector is typically the vector AB. So I take OB minus OA, I get 1, 1, minus 1. So once again, you're interested to know whether or not this line, how this line interacts with this plane. So let's check it firstly. Firstly, let's check it. L, is it parallel to plane pi? Right now, so because this is 0, therefore it is parallel. Number 2, you check. Take the point 0, 1, minus 3, you dot product with 1, 2, 3. What do you get? You get minus 7. And this is not 26. So therefore, by 1 and 2, the diagram looks like this now. The line is here, and then the plane is beneath it. This is the plane pi. Okay, so this is how the diagram looks like. In this particular question, apart from checking, now that you have checked and found that the line is parallel to the plane, and so therefore the line will not meet the plane, the next thing you want to know is what is the shortest distance between this line and this plane. Since they don't meet, we can talk about the shorter distance between the line and plane. Now, the shorter distance between the line and plane is roughly, this distance you tend to find. So to find the distance between the line and plane, if you look carefully, it reduces to just finding the distance from a point on the line to that plane. You know what I mean? Since these two are parallel, the distance between this line and this plane is the same as distance from this point to this plane. So therefore, you can use what you've learned earlier on to find the required distance now. How do you find the distance from a point to a plane? From this point to this plane again. To find the distance from a point to a plane, do you remember how? You take the point in question, 0, 1, minus 3, dot product with the normal vector, always minus the right hand side, modulus, and then divide by what? The magnitude of the vector n. So let's do arithmetic. This gives me 33. If you work it out, okay, this gives me 33 over square root 14. This is how you can find the distance between a line to a plane. Of course, the line must be parallel to the plane in the first place. Otherwise, there's no shortest distance to find. If the line is not parallel to the plane, it will meet, and therefore there's the shorter distance is therefore, if you like to, 0. Okay, let's do an exercise. This exercise is found on page 128. Page 128. Alright, in this exercise, the same thing goes, no? You want to find the shorter distance between a line L, between line L and this line L is 2, 2, minus 2, plus lambda, 0, minus 3, 2. And then the plane in question is this plane. 1, 2, 3, minus 7. Okay, let's do some of these things. We have done it many times, so let's do it more or less orally. Okay, line L and plane, are they parallel? Let's check it. Take this vector, dot product with this. You take this vector, dot product with this, right? It is actually 0. So the line L is parallel to the plane pi. How about this point? Is this point on the plane? Let's check again. Put this vector into here. You get 2 plus 4, 6. 6 minus 6 is 0. It's not minus 7. So therefore, this line is parallel to the plane, but it's not touching the plane at all. Right? It's like this. Same scenario. So because of the same scenario, now to find the distance between the line and the plane, how do you go? How do you find the distance between the line and the plane? Same thing, no? is to find the distance from a point on the line, which is 2, 2 minus 2, dot with 1, 2, 3, minus the right hand side. Be very careful, no? There are not minuses now. Minus of the right hand side, can you see? And then this over square of the magnitude of n. That's good arithmetic. 4 plus 2, 6, 0, 7. So I get 7 over root 14. Now we are into example 11. This example 11 is found on page 129. In this case, you are given a line and a plane. A quick check, you want to check that this vector, when dot product with this vector, right? You dot product these two mentally. This dot product is not 0. Can try. 1, 1, 1, 1, 1, 0, dot with 1, 2, 3 is not 0. Therefore, I know that the line is not parallel to the plane. Now, you want to know something, no? If a line is not parallel to a plane, I want you to know that if that happens, the line will certainly meet the plane at a point, this point. Right? If the line is not parallel to a plane, they will surely meet, and it meets at a point. In this case, we are interested to find this point. How do you think we can go about finding this point? Same thing again. This point, right? This point is on the plane. This point is on the plane, right? This point is also on the line, right? And this point being upon the line will look like the equation of the line. 2 plus lambda minus 3 plus lambda and then 1. Right? And at the same time, because this point is also on the plane, therefore it should also satisfy the equation of the plane. And there we have managed to form an equation that allows us to find lambda. So let's do it mentally. 2, 3, 5 minus 1 is 37. 3 lambda, I think lambda is equal to 9. Okay, check my arithmetic. So if a lambda is 9, therefore the point, intersecting point, what's the intersecting point? The intersecting point would be 11, 6, 1. What I did was, because lambda is 9, I put 9 into here. Right, this is example 11. In the exercise on page 130, on page 130, right, on page 130, there is a plane given to you. Page 130. This plane has this equation r dot 1, 2, 3 equals to minus 7. Right? Then in part A, it talk about a line like this. R dot 1, 2, minus 4 equals to lambda of 2, minus 1, 0. So given a line and a plane, so the next thing you want to ask, is the line parallel to the plane? Is the line parallel to the plane? Let's check it. If you take this vector 1, 2, 3 dot with this vector, right? What do you get? You get 0, right? So this line is parallel to this plane. This plane is given by notation pi. Let me erase off the. Again, I'm going to put like this. Demarcate them. Okay, right. So obviously, this line is parallel to this plane. It's parallel to the plane pi. And let's check the next thing. This point 1, 2 minus 4. You put it inside here, so you get minus 12 plus 5. And this point indeed lies on this plane. So it is parallel and lies in plane pi. Which means this entire line, like those earlier example, right? It is first and foremost parallel to the plane. And because this point is also on the plane, therefore this entire line actually lies in the plane pi. So if that being the case, there's no distance or intersecting point to talk about. Okay? part B. Part B is a line L3. Okay, so this line L1. You know. Okay, I don't know space. Let me put it in. This line is L1. Part A, this line L1. Right? In part B they talk about line L2. Part B, they talk about line L2. Over L2, the line joining the points. So L2 has this equation. 2 minus 2 plus lambda of 0 minus 3, 2. So there again, you want to ask what is the relationship between this plane pi and this L2? Let's check. Are they parallel? Take this vector, dot with this, you get 0, right? You get 0. Right? You dot product, you do it mentally. You take this vector, dot with this, you get 0, right? So therefore, this L2 is parallel to pi. So next thing we check is this point on this plane? Let's plug it in. Put it into R, it dot product. 2 plus 4, 4 minus 6 is 1. So but does not lie. That means this point is not on this plane. Therefore L2 does not lie in plane pi. Okay? So if the line L2 is parallel and doesn't lie in the plane pi, the next thing that we are interested in is the distance between this line L2 and the plane. How do you find distance again? Remember, we take the point in question, take the point on the line L2, minus 4, dot with the normal vector of the plane, which is 1, 2, 3, and then you minus the right hand side. Minus the right hand side, and then divide by the magnitude of the normal vector n. So let's do it mentally. 4, 5 minus 7 plus 7. This actually is, yeah. Okay, 5. Hey, I used the wrong point, sorry. I used the wrong point. I should be using this point 2, 2, 2. Sorry, I made a mistake. I should be using the point 2, 2, 2, 2 minus 2. Okay, let's check again. 2, 4, 6, 6 minus 6, 0. So there's 7 over root 14. Right. Okay, so there's the exercise on page 130. Then there's a part C. Okay, there's a part C. In the case of part C, right? In the case of part C, let me erase off this space here. Let me erase off this space here to do part C. Okay, to do part C, to do part C. Alright. In part C, the line given to you is L3, this part C. Of course, it's the same plane of pi r dot 1, 2, 3 equals to minus 7. And then the line L3 is r equals to 2 minus 3, 1 plus lambda of 1, 1, 0. Alright, so you're given this. Okay, you're given the plane pi and then the line L3. So check, are these two parallel? How do you check? You take this vector, dot with this, it is not 0 and therefore they are not parallel. If they are not parallel, they will surely meet. So to find the intersection between a line and a plane, the same thing goes. What you do is, you put the entire equation of the line into the equation of the plane. It's like solving them simultaneously, And then let's do the arithmetic. 2 minus 2 plus 3, this minus 1, minus 6, minus 6. I think lambda is equals to minus 2. Just be sure. Okay, so if lambda is minus 2, therefore the intersecting point will be 0, minus 5, 1. I put minus 2 into the equation of line, right? I get 0, minus 5, 1. And that completes the exercise on page 130. Okay, now we are on to page 131. Okay, in this section, we are interested to find the angle between a line and a plane. Alright, a line and plane. If you could remember, right, in my earlier video, I presented to you, if this would be a plane and this a line, the angle between a line and plane, right? It's very hard to see from here. I'm going to draw the plane just like a straight line and then the line like this. Okay, this is a line and this is a plane. I want you to be assured of something though, that the angle between a line and plane has to be the acute angle between them. Has to be this angle. Okay? And to find the acute angle between the line and the plane, we are going to make use of the direction vector of the line and the normal of the plane. Right? This is the vector parallel to the line. This is a vector perpendicular to the plane. We are going to make use of these two vectors to find the angle between a line and the plane. And it goes like this. No? Let me use example 12. In example 12, you have a line R equals to 2600 plus lambda of 3 minus 1, 2, and then a plane R dot 1, 2, 3 equals to 26. Okay. Now I want you to know that based on what we discussed in the earlier video, to find the angle between a line and plane is like this. No, is sine theta. Take this vector which is from the line, dot product with this vector which is from the plane. Then the magnitude of this vector, which is square root 14. Magnitude of this vector is square root 14. Now, to find the angle between the line and plane, we want to make sure that it is an acute angle. Right? Whatever it is, we always want to make sure that it is an acute angle. I want to assure you that that it is sine theta. Although these two vectors don't seem to sandwich the required angle, you will realize that the workaround is to use sine theta instead of cos. Usually dot product is cos, you realize that dot is cos, right? But just for this case, to find the angle between a line and a plane, I tweak it a bit so that I can get the angle right away. You see? I can get the angle right away. Alright. Of course, nothing stops you from saying this though. Nothing stops you from saying this arithmetic actually give me cos alpha, and this is alpha. Nothing stops you from doing this first, and then nothing stops you from finding the angle alpha first, then find the angle theta by taking 90 minus alpha. Nothing stops you from doing this. No? But I'm telling you that it is actually faster to just right away do this. And then if you do this, immediately you're going to get theta is equals to 6. This angle is going to be 697, 7014, so it's half. So therefore theta is equals to 30 degrees or pi over 6 radians. Okay, so I am advocating to you that we tweak things a bit. Okay, we actually use sine, something that you want to take note of. And then on the same page, there's exercise beneath. Same thing, no? To find the angle between the given line and the plane, again use sine theta. The direction vector of the line, which is 2 minus 3 minus 1, dot with the normal of the plane. And then again the same thing, the same thing. In this case, right? You get the angle to be equal to theta is equals to 30 degrees or okay, here, right, properly. By the way, I want you to know that my notation here and the notes a bit different, the other way around. Okay, the notes call this theta and call this alpha. Okay, I just write this note, call this theta, call this alpha. I've named them the other way around. Okay, I call this angle theta. So if you like to, you can just adopt the way I do things, right? the angle between the line and the plane, I call it theta. Right? And then you straight can find sine theta by doing this. So to give you a quick fix to find the required angle. Say again, my notation differs a bit from the notes. I have it the other way around. But doesn't matter, actually I prefer this way. I prefer to call the angle between line and pi, line and plane, to be the required angle theta. I prefer that way, no? Because we always talk about theta all the time. I try to find theta. Yeah. Okay, so that completes page 131.